Good morning, everybody, and welcome to the webinar this morning. And today we're going to be talking about sustainability in advanced manufacturing through collaborative robotics. My name is Shay Chalmers. I am a mechanical engineer by training. I did my undergrad and my postgrad at QUT, and I didn't actually get exposed to sustainability until I did my master's because it wasn't part of an undergrad when I studied it. So I'm really excited to have this conversation today. I just wanted to start the session by acknowledging the traditional owners of the land that we're gathered on today. For me, here in Brisbane, that's the Turrbal and Yagara people. And I'd like to acknowledge our nation's first engineers, manufacturers, and scientists, and pay respect to their elders past, present, and emerging. So I'd like to start this morning by welcoming our panelists. We have Gareth Keane from Cook Medical. Morning, Gareth. Did you just want to do a quick introduction on yourself?
Yeah, morning everybody. So yeah, I'm manufacturing engineering manager for Cook Medical. So I started my career quite a few years ago, back in the 90s, as an apprentice in manufacturing. And yeah, I guess back then the sustainability wasn't really a thing. And yeah, so I started as an apprentice, as I said, and then worked in various industries and tire manufacturing, the food industry, mining, and construction, and now I've actually worked in disability sector for a while as well. So that was interesting, in manufacturing as well. And so I've got a fairly broad experience of different industries and people, and then got an opportunity to come into the medical device sector, which I find very interesting and rewarding as well. And yeah, and from a sustainability perspective, that's something that we're looking at to it's a work in progress for us at the moment.
Thanks, Gareth. I'd also like to welcome Glenda Caldwell, Associate Professor at QUT. Glenda, did you want to do a brief intro with your history?
Hey, yes, good morning, everyone. Yeah, so I'm an associate professor in the School of Architecture and Built Environment. My background is in architecture, and I work very closely with colleagues from design. So I'm part of the Cobotics Center that's funded through the ARC. It's a training center, and I'm one of the co-leaders of one of the programs where we look at designing socio-technical robotic systems. So I'm really excited to be here today and talk about sustainability and what that means in terms of putting design methods and approaches into manufacturing processes and looking at how we adopt technologies and what that means to creating more sustainable outcomes.
Wonderful. Thanks so much, Glenda. And our last panelist today is Melissa Nugent, who's Business Development Manager at the Arm Hub. Mel, you want to do an intro?
Yeah, so my undergraduate degree was actually in environmental science. So this is a topic that's close to my heart, but I guess my history is project management and program management in a range of sectors, industry, government, education and research, usually in the spaces of innovation, technology and relationship management or engagement.
Wonderful. Thanks, Mel. Now, we might get started today because we're talking about sustainability and manufacturing and cobotics. And I think it's actually quite complicated when you really break it down. I think a lot of us have looked at the Sustainable Development Goals and we're at the position now in our lives, I think, where we're trying to figure out how do we apply these things to our daily work and what we're doing. And from a manufacturing perspective, I work across manufacturing sectors, from renewable energy projects to medical devices to other heavy manufacturing and boat manufacturing or coating. So I work across a number of different industries. And it's been really interesting to watch the different parts of manufacturing and how they're embracing on their sustainability journey. I think from a manufacturing perspective, we have always looked at lean as a way of operating. And for us in manufacturing, lean is about reducing waste and increasing efficiencies in what we do. So that really ties nicely into, I think, sustainability and the vision for the future. We've got a long way to go, but from what I've seen across industry, people are starting to see, what does this mean to me? And it's starting with energy and looking at their processes, looking at their people, and collaborative robots plays a really interesting part in that story. So I might just ask the panel firstly, what does Cobotics mean to you? Gareth, I'll start with you.
So Cobotics is a fairly new experience for me. So I haven't, I've had experience with robotics and automation, and but in terms of cobots, I think it's, I guess, understanding the definition of a cobot, you know, obviously working with people rather than replacing people. So what it means to me is enhancing manufacturing rather than replacement of, so to speak. So it's always, you know, in partnership with a person on the manufacturing floor. So, and it also gives people an opportunity to upskill and things like that. So there's many benefits to Cobotics and stigmas as well, no doubt. And so so we're working on, you know, a project, and realize that the stigma around proximity to a piece of moving equipment is potentially significant, and something that will have to be overcome.
Thanks, Gareth. I think that ties really nicely in when we're talking about the people element and how people impact Cobotics. Glenda, I might ask you the same question. What does Cobotics mean to you?
I think the key word to think about when talking about Cobotics is collaboration. And it is really about making robotic solutions that enhance or foster that collaboration between a robot and a human. And I think there's enormous opportunities to be explored into what that partnership, that collaboration, what that means for people across industries. Everything from, you know, of course, manufacturing, but also like the construction sector, and education, and how we teach people, and what that means for training, you know, upskilling. So there's so many opportunities that we can really explore when we consider collaborative robotics. And it's not just necessarily the robot itself, but it's looking at what does that mean across the organization, across, you know, from different levels, from the workshop floor, let's say, all the way to, you know, top management, organizational level, but also looking at what are the design considerations that need to be put into place for making the spaces work to enable that human and that robot to work together. Yeah, there's a lot of opportunities to look at processes, approaches, processes. So I think it's a really exciting term and a really exciting time for all of us.
Wonderful. Thanks, Glenda. Mel, what about you? What does Cobotics mean to you?
I think there's probably two big dimensions for me. The first is that Cobotics is just one of a suite of Industry 4.0 solutions, and often people jump to thinking the solution is a robot or a cobot, but really it's about thinking through what is the process you're trying to achieve and the production and the outcome. And it's all about productivity and competitiveness for our industry as a whole, thinking about it from that lens. And the second thing I think is that we often focus on the arm or the hardware, but Cobotics is really about a system and a solution, and thinking through the endpoints and the inputs and the outputs is often more or just as important as thinking about what the actual cobot's going to be doing.
Yeah, absolutely. And I think I asked that question because cobots and collaborative robotics, it's a problem, it's an opportunity for problem solving. And I think what it means to me, given my history, I've worked in predominantly male-dominated fields my whole career, and it's interesting to see that when we look at the human element of it, I believe that cobots can actually play a really strong role in diversity and equality. So an example of that in production, we had typically male roles and female roles. And some of those were to do with human traits like strength. On a food production facility, for instance, we'd have the guys often at the front of the line because they were working with the heavy, moving the flour or moving those heavy things. And then we'd often have the women at the end of the line because they had a real ability to do with fine motor skills or with their quality control. And we certainly, that was typically how it used to happen. But what we're seeing with collaborative robotics is that it doesn't, if we have robots to support the humans and lean into some of those areas, for instance, we don't need a larger person to be able to move the flour around when you have a robot to work with you. Or similarly, so at the end of the line, if you've got a vision system or a collaborative robot that has vision ability or QC ability, you can work in combination. And so I think it actually plays a really strong role in equity and diversity so that we can put people of all different types into all different roles and support them with a mechanical system to help do that as well. So I think we might now lean a little bit further in. So I'm trying to take you on a journey because sustainability, cobots, manufacturing, they're kind of things that are all coming together at the moment. But I might just ask the panel, how do we believe that cobots and automated manufacturing, how does that tie in to sustainability and the UN sustainability goals? So if you reflect on what you're doing, Gareth, I'll start with you first, but what you guys are doing at Cook and how does process optimization tie into sustainability?
Yeah, so I guess what we're looking at Cook is, I guess, some of the challenges we've had recently around the labour footprint and safety and making manufacturing an attractive place to work is, I guess, has become more and more of a challenge. And I've seen it over the years. And, back in, we talked about lean before, Shay, and, really lean was about, and some of the industries I've been in was about automation just to replace people. And that's changed a lot, I think, in recent times where manufacturing, for the employment market at the moment, it's becoming harder and harder to recruit people. People don't like to do shift work and those other things. And we've got I guess we're just not accepting some of the safety challenges that are presented in the manufacturing space more and more, which is great to see. And that's where Cobotics has really come in, we talked before about Cobotics not being the only solution, but Cobotics generally having a part to play in some of the challenges we've got and some of the dexterity challenges we have in the medical device sector sort of lend itself to our potential RSI injuries and the like. And we've got a multitude of opportunities where a cobot could play a part in some of those areas where we're trying to be stronger in that. It's not just about a cobot, but semi-automated processes as well, where you can semi-automate a particular function where it's pushing the tube into a bung or the like. And in this case, we've actually looked at a solution where and looked at it from a broader standpoint, and we're in a partnership with a project with the Cobotics Hub at the moment, where was a cobot the right solution for this problem? And so looking at it holistically from the start and then saying, well, it's not just about the cobot, there's also the other systems that you're attaching to that cobot, and can we come up with a solution that will likely come up with a solution? So that solution is going to not only give us a capacity increase where the component that we're looking to make, or that the cobots are going to assist us to make, is some capacities made in the US. So there's a transport requirement for that comes out of the USA. So our sister site makes a portion of those components because we just can't keep up with the demand here. And so it gives us the opportunity to bring that manufacturing into Australia totally, so that we're doing all those components here at Cook Australia. So there's that benefit. So that's obviously going to have positive impacts on the carbon footprint. And we've got the labour impact. So we've got a safety implication, as I said, with RSI, but there's heat and soldering irons involved in this process. And, at the moment, it's just accepted that people may burn their finger from time to time. So we can take that risk away by having a cobot solution to assist with that process. So, and the other benefits are, having someone upskilled to work with a cobot, and, the possibilities for programming or getting involved more in the cobot and the operation of that cobot's an opportunity too. And I think it's going to help us with attracting people to manufacturing when we've got new innovative solutions. So it is complex, as Shay talked about, and there's lots of benefits, and there's lots of different pathways you can talk about that they can help us with.
Excellent. Thanks, Gareth. I think it's an interesting conversation too about the reduction of carbon footprint, because during COVID, we're seeing a really interesting trend. Probably the last 20 or so years, we've really looked at consolidation and economies of scale and reducing what we deemed was the risk at the time by having large scale production facilities in one or two places. And it's actually interesting to see how that shift is changing through COVID, because when we've got long, complex supply chains, increasing logistical costs and increasing awareness on our carbon footprint for the life cycle of the entire product, people are really rethinking the way in which they do manufacturing and how they distribute that. So we're seeing a really interesting trend, which will be interesting to watch over the next couple of years, around decentralization of manufacturing. And it's actually becoming really beneficial for Australia because we're a really good springboard into the Asian market. And it actually, rather than sending stuff from Europe or the US, having some kind of decentralized manufacturing facility here for US-based and Europe-based businesses, and increasing the scale of our Australian manufacturers here is something we're seeing huge demand for, which is really interesting from a Cobotics perspective, because when you've got one massive facility, you'll have one very efficient process with very expensive equipment, and you get that economies of scale through the sheer volume and your process design. When you go small, you need to really think smart about how can I design my process to be replicable in a small scale. And that's where cobots are really, really important, because humans are different in different nations. We have different cultures, we have different needs, and cobots are flexible in a way that you can design the process, deploy it anywhere, and actually look at that small scale manufacturing as a little bit of a different lens, I think. Mel, I might hand over to you, because I know you were talking about not just the decentralization of manufacturing, but also the bespoke nature of manufacturing and that high customization. So how does that kind of tie into Cobotics and sustainability from your side?
Yeah, I really agree with you, Shay, around thinking about sustainability in terms of not just an individual business's footprint, but our national footprint and what we're doing around sovereign supply chains and the role that Cobotics can play in that. What we are facing in manufacturing, I think, is, and Shay, you touched on this, is that we're not really doing, the mass production of one or two items and a bazillion of them. We don't have that scale of market. What we've got is high volume, high variability. And so what we're seeing more and more is people looking for ways to be more effective in producing high volume, high variability. And Cobotics just plays such a massive part in that picture and that future. I think too, we think about sustainability often in terms of efficiency and waste, and robotics have been shown to play a really positive role, and collaborative robots can too. And I think the more we apply other related systems like better use of data science, better use of computer vision and those associated systems, we improve quality control and reduce waste further and further. So it all plays into it. But I think there is another angle that we need to think about in terms of sustainability, and that is even for traditional industries, with the rapid move towards net zero, traditional industries are now starting to see the market opportunities there. And even in areas that you may not think about in terms of how we're going to get to zero carbon, such as steel manufacturing, which is really important to Australia. Now, steel manufacturers are starting to turn their attention to, well, how are we going to very rapidly develop the infrastructure for net zero? How are we going to rapidly develop the, the capture, the supply, the transmission, all of that critical infrastructure, and how we're going to do it quickly and effectively. And really, we don't have the capacity in our country to do that in any other way other than by really thinking about the role that cobotics and robotics and automated solutions can play.
Yeah, awesome. You get me excited talking about steel. I am a old steel mill worker from way back. It's one of my most favorite places that I've worked in my career was a consolidated steel mill in the US. And I think it's really interesting because when you look at the commercial imperative around sustainability, steel is a really good example, because we're already starting to see tariffs come in. Europe's leading the way with that. So there will be a tax on products and services that cannot justify their sustainable provenance. Like it'll be provenance. It'll be really interesting to see as we move. And green steel is such an interesting concept for us here in Australia, because a big portion of the carbon footprint around steel, obviously you've got the iron that is a raw material, but it's also the energy. And from an energy perspective, Queensland and Australia is incredibly well placed. We've got lots of sun, we've got lots of land, we've got lots of options to deliver energy in a renewable way. So that gives us a pretty darn good value proposition for green steel. We even, back in the day, steel is quite an interesting product because it is 100% recyclable. And in the mill that I worked in, we actually had an electric arc furnace that was pretty much just fed through scrap. And so there's an entire, steel's been for a very long time, just because of the challenges with getting raw materials, has been looking at that circularity of how do we utilize our scrap? What are the systems and processes to get it in? How do we design new methods like a EAF to be able to produce steel in a way that's sustainable? But that at that time we used coal-fired power stations to power the EAF, but I think we're getting to a point now where we can really start to think about that. So there's some pretty awesome opportunities here for Queensland. And I think I saw a CSIRO report from Data 61 about green steel. In 4 years, they reckon it could produce tens of thousands of jobs. I can't remember the exact number. I think it was around 14,000, but there's economic imperative as well as the environmental one as well. So I might just touch on that a little bit, Glenda, around waste reduction. And so it's a really important part of, one of my favorite textile engineers said, we're going back to the future, but it's really about thinking about what our grandmothers did, waste not, want not, and incorporating circular economy principles into what we're doing. So I'd love to hear you talk a little bit about waste management in manufacturing and how that aligns with Cobotics and your thoughts on waste reduction.
Oh, thanks, Shay. So I think it's really important to highlight the difference between an industrial robot and a collaborative robot. So industrial robots tend to be very large. They don't have any inbuilt sensors or any intelligence. So it's really about a human programming what that industrial robot needs to do. And typically industrial robots are what we see on large production chains of, let's say, like automobile manufacturing, where it's one robot, it's partitioned away from humans so that it is safe to be used. So people are separated from that robot operating. The difference with a collaborative robot is that a collaborative robot will have inbuilt sensors into the robot, and these sensors will enable a human to work more closely in proximity with that robot. So it has these safety features that make it more useful or more applicable to more scenarios in more parts of the manufacturing process, as an example. collaborative robots also tend to be easier to program and easier to control. They tend to be smaller, right? And also that helps them in terms of being safer. But because they're smaller, they may not be able to have the same strength, right, that an industrial robot has. So there are some limitations in terms of how much force it can apply. But also it will have limitations in terms of how much weight it can carry, what its payload is. So it's important to consider these limitations when thinking about how and where and when to implement or adopt a collaborative robot in comparison to industrial robot. But it has massive benefits that we've already been talking about. And in terms of, the informing the ability for manufacturers to customize, and that's really where we see a huge area of potential, where these sort of smaller, more adaptive, more agile, collaborative robot solutions or processes can be implemented into these customized manufacturing processes. And it will help manufacturers create processes that are more efficient in terms of how they use materials, right? And how much waste is generated in that process. And that's where I think addressing the SDG goal around responsible consumption and production, that's goal number 9 or 12. And so I think there's huge potential there, because we can design processes, we can design end effectors. So end effectors are the tools that you attach to the collaborative robot. So you can really start to work, I guess, in a more adaptive way with the nature of the materials that are being worked upon, and also really start to consider what the amount of material is used to create the product, but also what is the, how do we capture the waste that is created, and then how do we repurpose that waste and think more intelligently about how we can reuse that waste into other processes. And what you talked about in terms of onshoring manufacturing, that also allows us to create this circular economy in a more localized way, right? So it's one thing that's really exciting about the Australian Cobotics Centre is that we've got a number of manufacturers that we're working really close with, and they tend to be in sort of localized areas, and we can start to think about, well, what is the, what are the where are the materials coming from to create certain products, and then where is the waste being generated, and how can that waste be repurposed in other sectors or for other products. So there's a lot of things that we can really start to look at. So it's not just, as we've already mentioned, it's not just about adopting that hardware, but it's thinking about the system as a whole, and really looking at how we can create conversations like today, where we can learn from one another, and approach things in a really collaborative and open-minded way. So we can, share what we're learning and say, okay, I've got this waste coming from this process, who can use it and what can we do with it?
It's a really good point about so I think, manufacturing is actually one of, I think it might be the second largest carbon emitting industry. I think it's behind logistics and marine shipping from memory. But so we have a lot of opportunity for us to optimize what we're doing. And thinking about it from a waste perspective is a very natural thing for manufacturers to do, because we're always thinking about reducing waste in our production line, whether that be waste of movement or waste of raw materials or waste of, when you look at the different elements of lean, it's all about reducing waste. But I think it's probably a reasonably new thing over the past couple of years, where we're really thinking about byproducts as a waste and byproducts as a feed into something else. And so what I'm seeing with a lot of businesses is they're actually thinking, okay, this might be my waste, but where is this a fuel source, or where is this something that somebody else can use? And from a Cobotics perspective, it's an enabling technology. Like textiles is a really great example because it's one of the most horrific wastes that we have globally. But managing that recycling or repurposing or redistributing those products is really tricky. But when you have things like cobots that have potentially associated vision systems, they can look at it and say, color, I'll color match and then I'll sort. Or it takes a lot of that labor intensity out of the sorting, the filing, and therefore trying to find a person who wants that waste. But Mel, did you have any comments on or examples that you guys have seen at the Arm Hub of when cobots or robots have been used to sort or things that we wouldn't have typically found a value proposition for in the past?
Yeah, the textile one is a really good example, Shay. So we worked on quite a large project with QUT, Kmart and Salvation Army recently. And I say it's large in terms of it was really broad with its stakeholder engagement, but it was quite a small focused project. And it really looked at what's going on in the value stream for textiles and why is it so hard for us to change the way we conceive of textile use and textile waste. And one of the biggest challenges in that supply chain is the sorting of the waste streams. It's really complicated. So I think as it's a really good example of where we often, as Glenda mentioned before, we often thought about robotics as quite an, the technology wasn't very smart. It didn't have a lot of smarts in it. It was just basically point and shoot, do the same job over and over again. Whereas now with the the rapid acceleration of data science, machine learning and other forms of AI, we see so much increasing potential for cobots and other solutions that are like cobots to tackle some of those really challenging supply chain problems, like how do you sort complex waste streams? How do you effectively manage quality when you're dealing with really precision systems, and how do you automate your processes with that in mind? So I think the coupling of data science, particularly machine learning, AI, all of those numerical technologies and vision related technologies, that's changing the nature of cobotics and what it can do. The other thing we're starting to see is, and this is a really, I think, very valuable and important use for cobotics, is that cobots are fantastic for testing the feasibility of solutions. So before you invest in a very expensive robotic system, you can, and we do this quite a bit at Arm Hub, and we've done this for a few industries, but you can test whether it's feasible and in what combinations and what sort of system requirements would an automated system, would a robotic arm best look like at a reasonably low cost. So we're able to now use cobots to accelerate technology and system development.
Thanks, Mel. I've popped it in the chat, but just to let everybody know, we are going to be going to the panel in a few minutes to ask questions. So feel free to pop it in the chat, or you can also just come on and talk as well, but get your questions ready for the group. Gareth, I might run to you and just kind of have a bit of a discussion around what you guys have been seeing. I mean, Cook's got a pretty large global supply chain. Has there been any changes that you've seen in your supply chain around sustainability, or what businesses are doing in different regions? Or is there any trends that you're seeing with the medical supply chain? It tends to be a bit challenging because it's regulated, so it moves slowly, but I'd just be interested to hear your thoughts on that.
Well, yeah. Yeah, obviously regulated makes it very difficult to adapt. And it's really been about survival at the moment. And so I guess sustainability, well, it's sustainability considering the supply chain, probably what we have looked at is in lieu of having an external outside Australia provider not being able to provide for us is looking locally. So we've there's been a couple of cases where we've looked locally in our supply chain rather than internationally for a particular component. Things like silicon, the shortage of silicon and the like has really played a part and meant that we've haven't had many options to our supply chain to stay in business, if you like. So there's various, obviously thousands of components that we use and materials, and the sites in the US have got the same challenges. But what's been good is that because we are got a strong global footprint, it's helped us in that we're able to source and share materials just to get us through and continue continuity of supply. So I think you talked about the proximity to the Asia market before. So I think that's been a benefit to us. So that's helped us with supply chain perspective out of there. So obviously from a cost perspective, that's been beneficial. But I guess it's just a general acceptance of that we're in this mode, and it's not necessarily going to end soon. We've got increased costs with that. Obviously, the supply chain transport costs have escalated significantly. So yeah, we'd love to be able to. We're actually looking at dual supplier models, but that's not from a sustainability perspective. Well, it's sustainability manufacturing, if you like.
There's risk.
Yeah, it's risk. Yeah, so yeah, that's really where we're at the moment.
For those that don't know, there's a global silicon shortage, particularly for medical grade silicon, and that stems back to the fact that 2 companies supply that globally, and they're very, very, very centralized manufacturing. And it's an interesting example, the silicon one, because it's just one of those components that's so crucial to what we do, but it's very restricted in its supply, and it's very difficult to scale up. And we're finding that across a plethora of base materials. We have a lot of the ingredients here in Australia that for most materials, but they get shipped offshore to be produced, and there's very little actual raw material chemical manufacture that we actually do here. So it's creating some pretty serious challenges in manufacturing. In addition to what Gareth touched on, we've got increasing cost of supply chains, we've got increasing cost of insurance, we've got increasing cost of labor. Pretty well everywhere you look at in manufacturing at the moment, it's increasing costs. So there's certainly a real dichotomy we're struggling with at the moment, where we're trying to head down this path of carbon neutrality. There's an intent and there's a passion to do so, but you've also got to try to sustain business at the same time and manage all the risks associated with the global disruptions and geopolitical insecurity that we have. So it's a very interesting time. Sean's just come through with a question, just picking up on Mel's comments about Industry 4.0. Do we know of any work looking at the business model and value proposition of Cobotics? Sean, did you want to add to that question at all? Thanks, that's a great question.
Yeah, thanks, Shay. Thanks for the discussion so far. It's great to see different perspectives on the same challenge that we are all working on. I'm interested to Industry 4.0, while it's, you can call it, a digitalization or, of advanced manufacturing, it really is about a new business model for the for the organization that is adopting it and integrating it. And it really comes particularly from a consumer driven perspective. So how can we have perhaps one way to look at it is customization at scale, or however you want to term it, but ultimately it's looking at how an organization creates value for its consumer, its clients, or further up the supply chain. Just interested to know if any organizations, either from a framework perspective, or if there are some case studies that are out there that demonstrate the inclusion of cobots in an Industry 4.0, or at least an advanced manufacturing process, is driving value for why they exist.
Great question, Sean. Does anybody, Mel, you've got your mic off. You want to jump in?
I'll have a first stab at that. We're just because one springs to mind immediately, in that we're looking at developing up a case study. Particularly, I think it's seeking to answer that question with Omron and a company called ProPlaster. So one of the challenges in that answering that question is that it really depends on, in a way, what that production was doing and how the cobot, the ROI in that production, and it can vary so dramatically because cobots are used in dramatically different ways. But what we're trying to do with the ProPlaster and Omron case study is give an example of just that. And it's the example that shows that it's about that company thinking through the people and the process and the system with the technology being applied has got them the ROI and the benefit. So it would be fair to say, I think, that if you just shoved a cobot in there, you wouldn't get your solution. But if you think about the cobot as part of that system with the processes and the people and the culture and the technology and information, all of a sudden, well, not all of a sudden, but you know what I mean? When you think about it holistically, the ROI is definitely there. And there haven't been a lot of case studies around, and that's why we're working on one at the moment.
Yeah, there's a few underway. I think that where I've seen that value proposition from a business perspective be successful is when there is a need for, like, a quality need in the process. So a couple of examples that I can think of where businesses have done this internal assessment is decentralized manufacturing of batteries and also electrolyzers. And they're kind of similar in when part of that product requires very consistent layering of it's got a high quality repeatability. It's a very, if you did it with humans, it would be difficult to get the repeatability that you need. And so that's one where I've seen it being, again, like these facilities are still under design, but where the ROI stacked up to say, right, the investment in this is really about the production process that is required, and also the data that you get from the equipment itself. If you need something where you have to have the quality data inputted, and it's either a manual measurement or integrating it into a system with something like a cobot or a repeatable robot that works as part of the greater production line, that's where I've seen internal business cases make sense. And oh, sorry, Sean, you go.
Yeah, there's a fundamental paradox in some respects with cobots and Industry 4.0, in the sense that Industry 4.0 is effectively supposed to lift the human above the whole process, and that they're looking at it from a systems perspective. But a cobot, by its very nature, is integrating with humans in that production process. Yet it's digitally enabled, and yeah. I'm just interested to hear your thoughts about how industry, well, we might need to change the definition of Industry 4.0 or evolve it or something like that, but it does certainly the original definition and framing of Industry 4.0 was that there were no humans involved in that process at all. I mean, that's an ideal state, clearly, but cobots is really keeping them involved.
Yeah, Glenda, or did you want to jump in on that?
Yeah, just talking about the evolution of Industry 4.0, we can look to Industry 5.0, right? So European countries and other parts of the world are really starting to think about and talk about Industry 5.0. And just as you say, Sean, they are putting the human back into it. And that's where human-centered design will really play a strong role in how we create what this Industry 5.0 will look like. And that's where there will be ongoing opportunities for technologies like collaborative robotics and artificial intelligence and robotic vision, and so many other new things that are on the horizon. But I think, yeah, there is a shift into thinking, well, it's not just a technological solution. That's not enough. That's not going to get us where we need to get to. And really, we need to think about how do we involve humans in the process, right? How do we design with them? How do we create with them? How do we address their needs? How do we motivate people to adopt and learn and grow their skills so that we can address these big challenges that we're facing? So yeah, you're absolutely right. I think it is about putting that human into it. And there's yeah, I'm keen to hear what Gareth has to say about if you know about, or what your thoughts are on Industry 5 and what that might look like.
Yeah, I think we've skipped Industry 4.0, and Industry 5.0 sounds more like us, because we very much need the people as part of that. Yeah, vision systems, things like that that we can use. Touching on the QA side of it is a big benefit for us. So we're looking at things like process control and being able to read data automatically, because obviously we're regulated, we've got compliance, so we need to be able to record those QA parameters easily and effectively. A lot of that's done manually. It's tedious. Using sometimes, in some cases, basic as equipment as a ruler to measure a dimension. And so, there's smarter ways of doing that. We're looking at digitization and digital twins of a manufacturer component to utopia is to be able to output the overall dimensions of a component after we've manufactured it, and it go yes, no, that's passed, and all the data is recorded into a cloud-based environment. So yeah, that's a little way off. That part's a little way off for us, but we're working on the tangible stuff you can see, and Cobotics is part of that. With the next steps with Cobotics will probably be from a QA perspective, and even enhancing the current project we're working on with a vision system, an end effector, something along those lines that can help us with the QC side of it. And so you talked about ROI as well. I mean, the benefits on that are, we're looking at the ROI component now, but there's many benefits to that, and waste is part of that. Just the solution that we're looking at is there's a reduction in waste straight off the bat by being able to the cobot allows us to reduce the waste of a particular material that we use in that component, just by the nature of Cobotics and its ability, the dexterity that it can give us in that process. So yeah, there's and we'll start, obviously once the project we get further in the project, we'll start some of the further ROI benefits will come to light as well. So
and I think, Gareth, it would be a very similar assessment for a cobot as it would be for any other piece of equipment or any other process optimization, right? That value proposition and ROI is the same process.
Yeah. Well, and in some cases you wouldn't be doing it otherwise. So
yeah, absolutely.
Yeah, absolutely.
Excellent. Thanks, Greg. I see you've got your hand up. Welcome.
Yes, I do. And here I am at the Arm Hub.
Hello, I'm next door.
Yeah. So listen, case study of adoption of cobots and relevance to the business model. I did an interesting interview with UAP's general manager and also their spin-off as well. So on the basis of that interview, there's a lot of ways that cobots are working at UAP to drive value, and that's kind of what Sean's original question was about. And I think it's really interesting case study because it's not just about reducing costs, right? So here I think there are 7, right? So, and this is Amanda and Ben Tate, sorry. Yeah, Ben Tate I interviewed. So lower cost, obviously. Increase quality and therefore price. Improve supply reliability and on time and therefore price. Increase speed of prototyping of process and product improvements to expand revenue. Increase speed of prototyping of whole new product classes. And then also the one that is very important, and I think it's often overlooked, is just the market perception of technological superiority for the vendor, for the company manufacturing. And yeah, I think the cobots augment human ability, but they can't. Any robot can replace humans, and going to like a macroeconomic perspective, there are 3 scenarios for the adoption of robots and AI going forward. There is, the first scenario is basically the automation scenario that we've got, where automation or the adoption of these new technologies lowers price so drastically that it increases consumption, and that means there's going to be more employment for people because there's more consumption of better things, right? And that's a good thing. So that's a good thing for a country. The scenario you don't want is that these technologies just do a so-so improvement in cost. They're just like 3% better than a human being or 5% better than a human being. And if you're a company, you'll go, okay, I'll take the robot. But that's actually terrible for a country because it doesn't actually improve the revenue for the country at all. All it does is strip out employment. And then in the long run, that means less consumption and everything spirals down. And then the third one is, the third scenario is where these technologies can augment human labor and help them to quickly develop all these kind of improvements to the company that I just talked about for UAP. But also once you start doing whole new product classes, you get whole new companies springing up to deliver those, and you even create whole new industries. So just have a look at the games industry as a good example, right? There's no such thing in the game industry if it hadn't been for the underlying technologies. And now it's a whole huge global product thing. So that's my thoughts on it. And it's really exciting that we've got in the Cobotics Center the range of kind of skills and capabilities from business to hardcore engineering, to designers, human-centered designers, product designers, because I think that's what we need to do, is to have a really broad value creation kind of platform for ACC.
Thanks, Greg. And I think it's a really good point. And all of those deciding factors and what the value proposition is for a business to implement Cobotics is really interesting. But I think to add to that, though, the sustainability piece has also become a commercial imperative as a part of that list, because we're starting to see it as a must-have and not a nice-to-have, which typically in the past we've added it into our strategy as a side pillar that's like, okay, I'll put solar power on, or I'll do these things because it's a feel good. Now it's injected into the commercial strategy in every decision that we make, because we're seeing the writing on the wall that there will be a commercial imperative with tariffs and our social license to operate. So I think integrated into all those things you're saying, that sustainability piece is becoming core and not just an adjunct or an add-on that we put to make ourselves feel better.
I totally agree. And I forgot I was in a sustainability panel momentarily.
That's great.
But where that factors into what I said is I did say increase product and process improvements. And
yeah,
we need the capability of cobots to get sustainable improvements and sustainable product offerings back into manufacturing, like better energy systems and all those sorts of things. We need rapid prototyping to do that. We need startups to actually be creating those things. And so I totally 100%, 130% agree with you, Shay.
And I think it's interesting you forgot you're in a sustainability panel, because when we talk about lean and optimization and process improvement, I mean, those two kind of go hand in hand with sustainability, and it does feel like normal manufacturing speak, doesn't it? So Mel, I might hand over to you. You've got your hand up. We've got 5 more minutes.
Yeah, I just think we all need to remember that, you know, Cobotics, it's a tool and a platform. So while our mission should always be to remove the dull, the dirty, the dangerous, and to use these tools to do that, I think what Greg said is really important, is that it's a technology platform and it was devised by humans and it will be improved by humans. And the way it's used and adapted and developed, that's all about decision making and innovation and creativity. So that human as part of the system, as well as human, you know, looking at that system holistically and how it can be better, they're both critical roles to play. and critical to get sustainability outcomes, because as we all know, one thing about sustainability, it's never a quick win. It's always about how do you get the best out of a complex system for a better outcome for everyone.
Thanks, Mel. Absolutely. Glenda.
I just wanted to go back to Sean's question about case studies. And I think the center, working closely with, our different industry partners and the ARM Hub, I think that's one of the big values that we can deliver or aim to deliver, is to showcase more case studies about how collaborative robots are being adopted and implemented, whether it's at that prototyping stage or, farther advanced sort of stages of processes, and what that means in one company will mean something different to another company. And yeah, how can we learn from each other across all of that? And the other important point that I just wanted to reiterate that Greg mentioned is the different disciplines that are really coming together to address the research questions that we're all bringing into the center, but working together across the different programs and with our different industry partners. So hopefully in a few, each year we'll be adding to that story, adding to that narrative, and being able to demonstrate more of these outcomes, so we can have much richer discussions as we, continue to evolve and explore really, what's the value, what's the benefit, where are the real sustainable efficiencies, and what does that really mean? I think this is just the beginning of lots more conversations like this.
Thanks, Glenda. And we have 2 minutes to go, so we might go with the final comments. I think on that note of collaboration and collaborative robotics and case studies, I think there's a really important piece around that. The one thing about manufacturing is that it's heads down, bums up, getting products out the door, fighting your fires every day. So telling your story is a very difficult thing to do. So thank you, Gareth, for making the time to be here today. And thank you to Glenda and Mel for all the work that you're doing in the Cobotics Center and with the research and in the ARM Hub and collaborating with industry, because collaboration is incredibly hard, but it is very valuable, particularly when we're trying to make new possible and implement new technology, new processes, and new systems to make a better world. So thank you to everybody for joining us today, and I hope that you enjoyed this session. Thanks.